Variables very simply represent a place in memory that allow you to store something. Variables in your code will be represented by names. You can name a variable practically anything you'd like. However, there are some naming conventions when it comes to variables, but for the sake of this video, that is unimportant. The main thing you should be concerned about is if your variable names are clear and make sense what they represent. While this is a drastic oversimplification of what a computer's memory is like, it is a good way to understand how it works. A computer's memory can be simplified like a grid of lockers. Each locker has a number underneath it which represents that locker's memory location address. Now let's create a variable and let's call it numapples. Right now numapples doesn't have a value just yet, but by creating the variable, it ties the memory location address of 1000 to the variable name numapples. I will talk about data types in a bit, but let's say the variable numapples was of type int, which would represent an integer value. And now let's assign numapples some value of 43. The variable numapples is now linked with the value of 43 because 43 is the value in that memory locker. Because the computer reads everything at the bare bones as binary, ones and zeros, you need to kind of tell the computer what kind of data it is. Data types essentially tell the compiler, the thing that interprets your code, what you want to do with that data. You are also telling the compiler how much memory you need for a certain variable by declaring the data type. Think of this as specifying how large of a locker you need to represent your data. Let's take a simple example of this binary byte. This is how a computer would read this information. But if we translated this same binary value into a number versus a character, we would get two very different answers. We would get 77 as a number, and at least according to how Java interprets it, this would be translated as a capital letter M as a character. So it is easy to see now how important data types are for the compiler. Now that we understand data types in general, let's take a look at what we call primitive data types. These are essentially the lowest level form of data types. A good way to think of them is that they have an easy and direct translation to binary. Think numbers, characters, and Boolean values. Let's take a look at how numbers are organized. Numbers are the only primitive data type that have a kind of hierarchy to it. That is because you can represent different types of numbers in code. The first branch would be whole numbers, otherwise known as countable numbers. For this you would use data types such as short, int, or long. The only difference between them is how much memory is allocated to represent the number. Therefore, you can represent larger numbers with a long, and if you only need to represent a small number, you could use a short instead. Next is obviously decimal values, otherwise known as floating point numbers. You would use a data type such as the double or the float. Double and float share the same differences that countable data types do, meaning the only difference is how much memory is used to store each. The difference between countable numbers and floating point numbers in the computer is based on how the binary representation is read. The countable numbers directly correspond to its number in binary, whereas the floating point number is read in its exponential form to allow for decimals. Char is a data type that represents characters. The way that this works is each character corresponds to a number. Each programming language has their own char to determine this, but for Java, it uses the ASCII table to do this. You can represent capital letters, lowercase letters, and other common keyboard symbols. You can even represent single integers as characters. But you must be careful, this is a character and not a number, meaning you cannot do the same operations with it as if it were a number. Finally, you can even represent an empty character with a char data type. Finally, there is Boolean. Boolean is the simplest primitive data type. It is simply just true or false. In binary, it is a single bit of either 1 or 0. Even though it is very simple, we will eventually learn that Boolean values are extremely important in other computer science concepts, so it is definitely still quite useful. Also keep in mind that there are a number of different operations that you could do with these different primitive data types. Primitive variables are just variables which represent primitive data types. Think of these as the data being placed directly in the locker. Here is the same example from before. The variable numapples is most likely of type int or of type short. Next, a char variable is declared and assigned the value of capital Q. Finally, a Boolean value named canYouCode is declared and initialized with the value of true. Notice how each value is placed directly in the locker. We can even update variables. If we update the variable numapples to 86, the value inside the locker is changed to a different value. Non-primitive data types are data types that refer to objects which are derived from classes. In plain English, we would describe an object of the type class, so an object from the dog class is considered to be of type dog. Reference variables are specifically for non-primitive data types. This means they refer to objects. The object is created somewhere in memory, and the reference variable then points to the spot in memory that the object begins at. Think about some complex object. It is not very easy to represent that object directly in binary in one locker, so it is much easier for the reference variable to point to where the object begins. Let's see what this might look like using the locker analogy. So the very first thing that happens is the object is created in memory. At the bottom, we see the data for our object. The variable firstDog at the top thus points to where our object begins. Another way that you could think of this is that the locker with the reference variable contains the memory address for the locker where the object starts. Like I said, this is a gross oversimplification, but nonetheless it is a good way to begin to understand variables in data types. The final thing to consider is what happens when we update what our variable firstDog points to. Now let's create a new object in memory. When our new object is created in memory, our firstDog variable is initialized to that new object. We see that the variable now points to our new object in memory. Take a look at what happens to our other object. There is no way for us to access it now. Because no variable points to it anymore, we no longer have access to it. It is simply stuck in memory. Some languages like Java have the trash collector to clear the memory in cases like this, but other languages like C do not, and you have to update memory by hand to prevent memory leaks. And that's all you need to know to understand the very basics of variables and data types. If you enjoyed it, feel free to like and subscribe. Thank you for watching.